So today my topic is about basics of brain computer interface and its application. How we are using this brain computer interface in a human life and how we are connecting these EEG signals with the computers. So let's begin this chapter. So abstract. So it enables the direct communication between the brain and the external device, which we given the neural signals to the computer and we extracting the meaningful information from the brainy noises. So after we have many steps to abstract the EEG signal. So it does not depend on the muscle or peripheral nerves. It converts the brain signals into the control commands. So the control commands will, for example, if you blink the eye, if you are blink the eye, if you are move the muscles, we convert the signals into the cursor signals like that. So for the block diagram, the signals were taken from the brain and the signal acquisition and process, and from that we have extracted the features and classified and we given to the output devices. So brain signal used in the BCI are EEG, ECOG, and MEG. So EEG is a non-invasive, which is encephalogram, which is taken from the brain. So it is a EOCOG is semi-invasive and high signal quality. So halfly it is invasive and halfly it is non-invasive, which gives a signal quality. So FNIRS, it will measure the oxygenation, how much amount of blood in the body and how much oxygen is present in the body. So we taken from that. So special resolution and is expensive. Why we have preferred EEG means it is safe and portable. It does not cause any problem to the body and real life signal acquisition and suitable for clinical researchers. EEG challenges in BCI signal processing, so they are very weak, such as beta, alpha, gamma, highly affected by the noise and artifacts. The artifacts is based on the movement of head. The noise is present outside the body, which means the external noise like that. So low signal to noise ratio, non-stationary and subject depends on the signals. So the patient cannot be stable in the same place, so it becomes non-stationary. It will not give a perfect continuous and perfect tone. So these are the challenges in BCI signal processing. So what are the artifacts in the BCI signal processing? Eye blink, muscle movement, and power line interface. Power line interface can be cleared or removed by using the notch filters. So signal acquisition and pre-processing. So for signal acquisition, we place the electrode on our head and follows international 1020 systems. So pre-processing techniques consist of amplification. If the noise is low, we have to amplify the signals, and if we amplify the signals, there will be the noise will be produced. So we have to remove that. So analog to digital conversion. The signals from our body is taken as an analog and it converted into binary input, that is zeros and ones, normalization. Purpose of this to improve the signal quality and preparing the further analysis. So filtering techniques removes unwanted noise from the EEG signals. Types of filter used is band pass filter, high pass filter, low pass filter, and notch filter. For band pass filter it's used for direct current and high frequency noise. So we will remove the direct current and the high frequency noise. So notch filter removes the power line interference, which I have said already. So digital filters that are infinite impulse response, infinite finite impulse response and infinite impulse response. Finite is minimum amount, we have the threshold value. So for infinite, we don't have a threshold value. So filtering improves the clarity of a brain rhythms like alpha, beta, gamma, and mu waves. Feature extraction, it converts the EEG signal into the numerical values, that is analog to digital. So time domain features are mean variance and root mean square wise. Frequency domain features power spectral density and fast Fourier transform. Time frequency method consists of wave transform and short time fast Fourier transforms. Spatial filtering. So enhance the task-related brain activity. The common method which is used in the spatial filtering is widely used in motor imagery, Laplacian filter, and independent compound analysis. So advantage of is to classification gives an accuracy value and it will reduce the noise and overlapping the signals. Classification techniques are two types: traditional classifiers and machine learning and AI. So classification converts the extraction feature into commands, so which convert into commands. So linear discriminant analysis, support vector mission, k nearest neighbor. So these are under the deep learning techniques. So machine learning techniques are artificial neural network, convolution neural network, then deep learning and adaptive for BCA. So deep learning is differ from the machine learning. Deep learning is if we give if we give input for the one time, it again didn't ask any of the input for recognizing. But in machine learning, if we give input for the first time, again when we are uploading another input, we have to give another input. So application, assistive communication for disabled persons. So brain control wheelchair, neuroprosthetics, rehabilitation after stroke. So many BCA techniques have involved or invented an ongoing process which will help the people to survey for a long time. Thank you.